Okay, this is Mr. Smith here. This is Algebra 2, Section 410. It's the last section in the chapter, and we are looking at quadratic functions and using them to model data. Okay, and so we've seen this before earlier in the year, where we had a set of data, and we had some nice pattern like this, and we said, well, there might be a linear regression or a line that I can use to represent the data. But we also realized that there was a limitation here because life doesn't usually happen in a nice linear pattern. Okay? And so now that we have some knowledge of a new family of functions, namely the quadratic family, that's what we spent our entire time focusing on, we're going to see that there are certain sets of data in certain physical environments that look something like this, and it wouldn't make sense for us to use a line to represent this data, but if we used part of a quadratic, we could see maybe we could get a new graph that would allow us to project or predict what's going to happen. Now, before we actually get on to the examples with the data, we're going to use a few examples that are actual functions. Okay? But I'm going to use the same technique throughout, and I'm going to rely on the calculator to assist us. Okay, so we'll use technology throughout our time together. However, I want you to see that we can do these by hand. At least at this level we could. Okay. So in this problem, they're asking for the equation of the line that represents this graph. And if we were going to do this by hand, we'd have to use vertex form. So y equals a x minus h squared plus k. Okay. Now remember, in vertex form, the h and the k are just values from the vertex. Okay, well, here's the vertex. They give it to us. So all we need to do, remember, the value here is shifted, so if it's positive 1, then it should say x minus 1. And so if I just substitute in, I get y equals a times x minus 1 squared plus negative 2 or minus 2. And now the only value I'd have to figure out is what is the a value. We just have to figure out what the a value is. And the way we would do that is we would use this other point that they gave us, 3, 2. Right, that's an x value and a y value. And so we would plug that x value and y value in and solve for a. Okay. So using vertex form, if I know where the vertex is, I can plug that in. And now the only unknown is what the scale factor is. And so we use this second point, this 3, 2. We plug in the 3 as an x. We plug in the 2 as a y. And now I solve this new equation for a. And then I'd have all the pieces, right? I'd have the h, the k, and the a, and I could rewrite the equation. However, I'm going to rely on the calculator to do this work for us. And to do this method, though, we need 3 points. We need 3 points. And so I have 2, and now I need an obvious third point. And it can't be one that we're just like, well, it kind of looks like one. We've got to be really sure about this point. And so in my mind, the easiest one is to take the knowledge of the axis of symmetry. Right? There's an axis of symmetry through the vertex. And so right here, I see that this is 2 units away here. So this must be 2 units away here. And so I'm very confident of that point, which is negative 1, comma 2. Okay? So I'm using the knowledge of symmetries to get my third point. Okay? So having 3 points, I'm now going to use the regression capabilities of the calculator to figure out what the equation of that line is. And so I first need to create a list of x's and y's. So I have negative 1, 2, I have 1, negative 2, and I have 3, 2. Okay. And so those are our x's and y's, and I'm going to create a spreadsheet. I'm going to create a spreadsheet on the TI-Nspire, so I'll go menu, and we'll go list and spreadsheets. We'll call this x, we'll call this y. And now we just need our values, negative 1, 2, 1, negative 2. Let me make sure I have this right. Negative 1, 2, 1, negative 2, and 3, 2. So 3, 2. Okay, and so we enter in the data. On the TI-84s or 83s, you're going to have to do this in the list. So you'll have to create list 1. There's a list editor. In list 1, you'll put the x values. In list 2, you'll put the y values. And then similar to what we've seen before, we'll do the regression. So we'll go on the Nspires, we go Control, and we add a new page. We use Data and Statistics. We click here to add the X values. We click here to add the Y values. And what you see is right now it's plotted all 3 points that we had. It's plotted all 3 points. And now all we need to do is go Menu, Analyze Graph, Regression. And what we used to do is show a linear regression, but we don't want a straight line anymore. We want a quadratic regression. So number 4, and there you see is our quadratic regression. And there, in the middle of the screen, is the equation of this line. Okay. So hang on one second. So the question was asking, what is the equation of this quadratic? If we were doing it by hand, we'd have to use the vertex method to figure out the vertex and then figure out what the scale factor is. If we want to use the calculator, all we need to do is get 3 points. We create a spreadsheet. We have the X columns, we have the Y columns. Again, on the A384, we need to create a list to do this, and I will help you individually after this video with that if you're struggling. And now on the Data and Statistics page, we label this as the X axis, this is the Y axis. It plots all 3 points, and then we go Menu, Analyze, and then we go Regression. And then we choose number 4, Show Quadratic. Okay. So let us do this again. Let us do this again, and this time we're going to look at a different problem. So on this problem, they don't give us the vertex. They don't give us the vertex here. But what they do give us is they give us the 2x intercepts. Okay, they give us the 2x intercepts. And so it's kind of like the problem that we saw at the end of section 4.8, we did in the homework, where I've given you 2x intercepts, x equals -1 and x equals 4. And if I ask you to write the equation of the line, you should be able to put it in factored form, right? If I know that the two of the solutions are x equals -1 and x equals 4, then the equation in factored form should say x minus 4, x plus 1. We're kind of working backwards. So this has got to be the general construct of the equation, but then again, there could be a scale factor out front that we don't know about. And that's why they have to give us this 0.32. That's why they give us this 0.32, so that we can figure out what the A value is. Okay. Again, if we're doing this by hand, you would plug in 3,2, you would solve for A, 3 is the X, 2 is the Y, right? So we'd solve for the A value, and once you have A, now you have all the information you need to write the equation. However, again, we can use the calculator's regression technique to solve this problem. Okay, so remember, if x equals -1, so that's the point -10. That's the point -10. It's the point 40, and then we have the point 32. And so if I make an XY table, we can go -10, 40, and 32. Okay. And so we have our 3 points, and we're going to repeat the process that we just used on the graphing calculator. So I'll enter these values in my spreadsheet. All right, so we come back here. So we have -1, 0, 4, 0, and 3, 2. 3, 2. Okay. -1, 0, 4, 0, and 3, 2. And now I'm going to add a new page. I'm going to add a new page. That's not the new page. There it is, Data and Statistics. Again, I'll choose this is the X, this is the Y. It graphs the 3 points for me. And now we go Menu, Analyze, Regression. Number 4, Show Quadratic. And you can see it shows the quadratic graph that goes through those 3 points. And here it gives us the equation. Right, here it gives us the equation of the line that was the one that goes through these 3 points. Okay, that's the idea there. We'll do it again. on this next problem, the by hand approach here is very unappealing. I'll explain the by hand approach, but I won't even venture to show it to you. So if we were to proceed on this problem and try to do it by hand, notice I don't have vertex. If I do have the vertex, I don't know that I have it. Number two, I don't have the x-intercepts. None of these points are x-intercepts. So I can't use the vertex method. I can't use the factoring, reverse factoring kind of method. So the only approach that you could use is to create a system of equations. And it would be 3 equations and 3 variables. And I don't know about you, but that sounds very unappealing to me right now. In fact, even setting up the 3 equations is difficult. So forget that. Let's just use our regression technique, right? I have -1, -3, 0, -4, and 2, 6. Okay. So this would be my list 1. This is my list 2. Or in my spreadsheet on the Nspire, I can just go in and create this. So we have back to this guy, -1, -3, 0, -4, and 2, 6. Okay, so there are my points. Again, I'll create a new page, Control, New Page, Data and Statistics. Click to add the X. Click to add the Y. By the way, there's some new things here. Don't worry about those new things. There are my 3 points. Menu, Analyze, Regression, Show Quadratic. And there's the equation of the line. Okay? And that was what this was asking, right? If you go back to the question was asking, write a quadratic function in standard form for the parabola. Here's the function in standard form for the parabola. Okay. All right. So we were kind of using a technique and applied in a situation that we maybe not supposed to, but it's very effective. But this is the problem where the technique is really supposed to be applied. Okay. So in this sense, what we have is a pumpkin launching catapult, because that's just amazing. And we have some data. And generally, regression is used for data. We're doing data analysis. And so, for instance, I might want to know, well, what's going to happen when if I take this angle and I shift it to 80 degrees. I know you can't see that, but if I shift it to 80 degrees, what's going to happen to the pumpkin? Okay. Or I may want to know the question, at what angle degrees can I get the most distance? That's a very important question to answer. And I can see on this data that it looks like at 40 that happens, right? It looks like at 40 that happens, but maybe it's at 44 or 45, or maybe it's before then at 38 or 39. And so I could ask the question, how can I get the farthest distance? Okay. And so I can use a regression technique. To do that. And so what we're going to do is we'll call the x's all these values in the top row, so 20, 30, 40, 50, 60, and so on. And the y's will be 372. And again, the y's have to correspond with their x's, 509, 501, and so forth. Okay, and for the sake of time, though, I'm not going to graph all of these. I shall just graph 4 of them using the exact same technique. But if you were going to do this fully, you need to graph every point, every data set, and see what you can do. All right, and see what graph we get. So let me go through here. All right, so 20, 30, 40, 20. Oh, I apologize. Hold on 1 second. All right, so I was able to enter the data here, and I just put a few of the function, show quadratic, and you can see here is the quadratic equation. Here's the quadratic equation that models the data with only 4 sets of data values. Now obviously, I think there were 6 or 8 sets, so if you put more data, you will get a more accurate result as what is going on there. Okay, but this is really where we're supposed to use a quadratic regression, and you should expect to see this on a future assessment. Okay, so this concludes section 410. Thanks for your attention. Have a good day.